Let's do this. So we're going to just take a look at a couple of real world scenarios where you could apply the things that we've learned from these previous trig videos, finding sides, finding angles, things like that. I'm going to skip the warm-up primarily because I forgot to put any information on the triangles. So we're just going to move past that. Here's an example of a situation where we could use trigonometry to find the missing information. A giant redwood tree, if you haven't seen a redwood before, highly recommend it. They are gigantic. Cast a shadow that is 532 feet long. Find the height of the tree if the shadow makes an angle of 25.7 degrees with the ground. I cannot stress this enough, and this will be the summary of the lesson. Before we even start the lesson, draw a picture. Your pictures don't have to be good. They don't have to look nice. Draw a freaking picture, because this is going to be very difficult to do without drawing a picture. And I am a hideous artist, but I'm going to go ahead and draw a picture of this. Here's my redwood tree. Casts a shadow that is 532 feet long. So what I'm going to do is I'm just going to draw a little dashed line. And this shadow is 532 feet long. It says find the height of the tree. So that's what I want to find. So I'm going to go ahead and label this as X. It's my unknown. If the shadow makes an angle of 25.7 degrees with the ground. So where the shadow meets the ground is 25.7 degrees. So here's my shadow. There's the ground. Where does shadow meet ground? Right here. That is 25.7 degrees. Okay. Now that we have something of a picture, okay, and I'm not going to pretend like this is a good picture, but it'll work to give me an idea of what I'm trying to do. I'm now going to draw that same picture just without the actual tree in it. So I have a triangle. Here's my 90-degree angle, assuming that the tree stands straight up. Here's what I'm trying to find. This is 532, and this is 25.7. If you can get to here, you can finish the problem. But with word problems, as you probably know, this is the toughest part, is taking words and changing it into something that mathematically makes sense, or something that you can do something with. So if this is the angle that I'm working with right here, that means I'm trying to find the opposite, and I have the hypotenuse. So I'm going to, opposite and hypotenuse is sine. So sine in parentheses goes to the angle, if I know it, and I do know the angle is 25.7, equals opposite over hypotenuse. Okay, and now I'm just going to solve this equation for the variable x. The variable is already on top, which is great because now when I multiply 532 to clear out the fraction, I will be ready to go type this into the calculator because the variable is already isolated. So just one last time, I know I mentioned in the last couple of videos, make sure when you click mode that your calculator is in degrees. If your calculator is giving you answers that are different than what mine say, it's probably in what's called Radians Mode. And if you're not sure how to do that with your calculator, please log in and ask your teacher, because every calculator is a little bit different. And if you have a different model than this, it can be, that button can be in a different spot. But every calculator does have, even your iPhone calculator has the ability to switch between radians and degrees. So 532 times sine of 25.7 gives me 230.706. So we'll say 71 feet tall, because remember, we're finding the height of that redwood tree. So the unknown value, or the height of that tree, is 230.71 feet, which would be about 230 feet and 9 inches. So draw a picture, draw a picture, draw a picture. Let's do another one. A 40-foot ladder leans against a building so that the bottom of the ladder is 10 feet from the building. How many degrees is the angle that is formed by the ladder and the building? Whew. Okay, So we have a building. There's the building. It's a very nice building. It's got a couple windows and a door. Okay, and then we have a ladder that's leaning against it. So I'm going to do ladder in red. The ladder is 40 feet long, so that's going to be the hypotenuse of our triangle. Okay. What else? The bottom of the ladder is 10 feet from the building. So the bottom of the ladder is 10 feet from the building. And then it's asking how many degrees is the angle that's formed by the ladder and the building. So where does the ladder meet the building? That's up top here is where the ladder actually meets the building. So this is what I am trying to find. Remember that circle with the line through it is theta, which is often a variable that's used when you're trying to find an angle. So we're going to draw that same triangle now over here. Oh boy. This is not to scale. There's my right angle. This is what I'm trying to find, and my hypotenuse was 40. So if we are, if we go through and label this, I have the hypotenuse of 40, and theta up top means that the 10 is opposite. So again, I'm going to be dealing with sine in this problem. What's different here, though, is sine of the angle, now the angle's unknown, is equal to opposite over hypotenuse. And I know that I can simplify 10 over 40 to 1 over 4 or 0.25. But I'm just going to leave it as a fraction. There's no reason to try and simplify and maybe make a silly mistake. If you remember, in order to find an angle, I need to get rid of sine. And in order to get rid of sine, I have to do what's called sine inverse to both sides. So I'm going to type in inverse sine of 10 over 40. Inverse sine 10 divided by 40. 14.47. So I'm going to call that, if I'm rounding to the tenths place, 14.5 degrees. And that is the angle that is formed between the ladder and where the ladder meets the building. 14.5 degrees. I could find the other angle if I really wanted to, but I don't care about that in this problem. So draw a picture, label what you know, and then do trig with it. Last problem we're going to do here, a little, I don't know, some young person with a green shirt and blue pants and pink shoes and a wagon with gigantic books in it is walking towards what I would assume to be a school. What is the height of the building, and what about the height of the flag? So there's a couple different things going on here. Okay, it seems that our young person is 5 feet tall. Okay, notice that 5 feet is not part of the bigger triangle. Okay, so what that means is that we're going to have to add 5 to whatever answer we get. So if I want to figure out what the height of the building is, the height of the building is this right here. Okay, so basically what that means is I'm going to figure out, I know that this child or person is 5 feet tall. So I'm going to figure out what the height from the top of his head. I'm going to figure out this distance right here using trig, and then I'm going to add 5 to that to find this answer. Now this triangle, if I highlight the entire thing, utilizes the 24 degree angle that's in blue. And since it's in blue, I'm going to re-highlight this. So right here, I'm going to use the 24. So I'm going to go down below here, draw myself a triangle. There's my right angle. This is 24. This person is 500 feet away from the building, and I want to know what is the height. So here I have the opposite, and I have the adjacent is 500 to that 24 degree angle. So I'm going to use tangent. So tan of 24 equals opposite over adjacent. If I go ahead and solve for x now, I can multiply by 500 to clear out that fraction. That's gone. 500 times tan of 24 equals x. So now I am ready to go to the calculator. You get 222.61. I'm just going to go to 0.6. So that is in feet. So what that's told me is that this distance from the top of this person's head is 220, what did I say? 222.6. So if the question is how tall, what is the height of the building? Height of the building is, let's go right here. It's that 222.6, but I have to add the 5 feet for the height of the person. So it'd be 227.6 feet. The question is, how tall is the height of the flag? Now, there's a lot of different ways you can do this. The easiest way that I can think of to do this problem is if I were to highlight now this big, slightly larger triangle in red. Okay, I'm going to put this in blue just so we understand that that was with. So all of the calculations that I just did would be the same, except now I'm using a 27-degree angle. So what I'm going to do is I'm going to take this and just kind of shrink it down so that way we can. Actually, I'm just going to copy this and paste it over here. So now basically what's happening is I am doing the exact same calculation, but my 24-degree angle is now a 27-degree angle. Okay, which means everything else stays the same except this is going to be 27. So it means times tan of 27 instead of tan of 24. So if I type this exact same thing in, do 500 times the tangent of 27, that's 254.76, which would be 254.8. So what that means now is 254.8 is the distance all the way to the top of the flag to there. So this is 254.8. So if I want to find the height of the flag, all I'm going to do is actually I can subtract these two values from one another, because the distance between those two will end up giving me the height of the flag that's on top of the building. So if I do 254.8, 254.8 minus 222.6, it's 32.2. So that then is the height of the flag, 32.2 feet. Okay. That's a longer problem and definitely a multi-step, multi-part problem, especially with the 5, the 5 feet tall of the person. I had to include that as well. But this is kind of the level of problem that we can do now using trigonometry. Summary, I'm going to keep it real short. Draw a danged picture. Doesn't have to be pretty, doesn't have to be nice, doesn't have to be AP art. Label what you know. And that's going to wrap it up for videos. If you're watching this in May of 2020, this is it for the year. So kind of crazy. Thanks for watching, and yeah.